This is Remote Learning Video Lesson 4 for Algebra 2. Today we're going to be reviewing our formulas for compound interest, continuously compounded interest, and half-life. So we'll just dive right into those formulas. So compound interest, please remember that it's A equals P times 1 plus R divided by N to the power of N times T. For continuously compounded interest, that is A equals P times E to the power of RT. And then for half-life, that's Y equals A times 1/2 to the power of T divided by H. And we're going to look at examples for each of these. So we're going to look at 3 examples in this video today. Now, example 1, we have Lisa deposits $1,500 into an account, and I'm going to just start underlining important things here. That pays 4.8% annual interest compounded monthly, and it's asking us what is the account balance after 3 years. So since it's telling us that we are compounding monthly, we are going to end up using just our compound interest formula, okay? And as I underlined each of those, we can start plugging those into our formula. So we're going to be looking for the end balance after 3 years. So our initial value, our principal, is $1,500 because that's how much she's putting into the account initially. And our rate is 4.8%, so we can change that to 0.048. Divided by compounding monthly. So remember, that's our end value, and that is 12 times a month each year, to the power of 12 times our t value, which is 3, okay? And so we can go ahead and just simplify some of these things with a calculator. So 1,500 in those parentheses, 1.004 to the power of 36. And so rounding just a little bit with money, after 3 years, she should have about $1,731.83. Okay? So make sure $1,500 is our principal. Our rate is 4.8% here, being compounded monthly, which is 12 times a year. After 3 years, she should have about $1,731.83. Okay? So let's move on to example 2. So here our example says, to pay for a trip to Machu Picchu in 4 years, Doug wants to deposit money into a savings account that earns 2.9% annual interest compounded continuously. How much does Doug need to deposit to reach $2,500? Now, because we see compounding continuously, we know we're going to use that PERT formula, P times E to the power of RT. And now we just need to figure out what values do I know to go ahead and plug into our formula. So I see our time is 4 years. He wants to deposit money into a savings account that earns 2.9% annual interest. So we have 0.029 compounded continuously. And how much does Doug need to reach $2,500? Now, don't make the mistake of plugging that into our principal, because that's not how much money he is putting in there initially, okay? We're figuring out how much money does he need to put in there to reach $2,500 by the end of it, okay? So we're going to use all of these values to start solving for our initial value. So we're going to have 2,500 equals P, because that's what I'm looking for, times E to the power of 0.029 times 4, okay? And we can go ahead and simplify that just a little bit to start solving for our principal. So I'm just going to make our exponent look a little bit prettier, multiply the rate times the time, and now we can go ahead and try to get P by itself. Now it's being multiplied by E to the power of 0.116. So now to undo that operation, let's go ahead and divide both sides. Okay, so 2,500 divided by e to the power of 0.116, we should get $2,226.19. These will cancel, and that's roughly our principal, which is how much money he needs to put into his savings account to reach $2,500 in 4 years. Okay, so that is compounding continuously. Now let's move to example 3, and we're going to look at half-life. So it says element X is a radioactive isotope such that every 23 years its mass decreases by half. Given that the mass of a sample of element X is 80 grams, how much of the element would remain after 21 years? And we're going to round to the nearest hundredth. So remember, here's our formula. A times 1/2 to the power of T divided by H. All right. And we're going to start looking at what each of these values represent. Okay. So if we read back through that, such that every 23 years its mass decreases by half. So H is our equals 23, which is our halving time. Given that the mass of element X is 80 grams, so that's how much the element starts off with. And then how much of the element would remain after 21 years. So that's going to be our value for T. And using all of these values, we can plug that into the formula and actually start solving. So we're going to have y equals A, which is 80, because that's how much our sample has a mass of, times 1/2 to the power of T divided by H, so that's going to be 21 divided by 23. Okay? And then simplify that, and we should get 42.49 grams. All right, so there are our 3 examples. So after watching this video, you can now complete lesson 4, lesson 5, and lesson 6. Each of these lessons are going to consist of practice problems for you to complete to review your compound interest, continuously compounded interest, and half-life.